Hello everyone, welcome to my channel. Today we will talk about the wave nature as well as particle nature of the radiations. But before we proceed, let us talk about few basic terms, few definitions like atomic number and mass number. Now, mostly in 1913, try to determine the exact number of positive charges present in the nucleus of an atom. And he did it by studying the nature of X-rays produced when different elements were bombarded with cathode rays. He termed that number of the unit positive charges present in the nucleus as atomic number. So atomic number is denoted as Z. Now how to define? It is simply defined as the number of protons in an atom. And remember, the number of protons are always equal to the number of electrons in a neutral atom, but not in the ionic species. Now the second thing is mass number. Mass number is defined as the sum of number of protons and neutrons present in the nucleus of an atom. So mass number is protons plus neutrons. Protons means atomic number means Z. So mass number A is equal to Z plus N. That is protons plus neutrons. Now the next is how to represent an atom, composition of an atom. Now atom can be represented by writing its symbol and then writing its atomic number and mass number in the form of subscript and superscript. For example, if element is X, Z atomic number will be the subscript and the mass number A will be the superscript. For example, let us say I want to represent argon. Argon has got atomic number 18, mass number 40. So it is represented as 18 Ar40. So 18 represent the atomic number or the number of protons and 40 represent the mass number, that is sum of protons and neutrons. Now next is isobars and isotopes. So what are isobars first of all? Isobars are the elements having the same mass number but different atomic number. They are just the reverse of isotopes. So what are isotopes? Isotopes are elements having same atomic number but different mass number. For example, hydrogen has got 3 isotopes. 1H1 means protium, 1H2 means deuterium, 1H3 means tritium. So these are the 3 isotopes of hydrogen atom. Whereas isobars are the atoms of different elements having same mass number but different atomic number. For example, argon, K, potassium, calcium, Ca. So argon, potassium, calcium are isobars. Next term here is the isotones. So what are isotones? Isotones are the atoms of different elements which contain same number of neutrons. For example, carbon C614, oxygen O816, nitrogen N715. These elements have got the same number of neutrons. How to determine the neutrons? Simply the mass number minus atomic number. 14 minus 6, 8. 16 minus 8, 8. 15 minus 7, 8. So they've got the same number of neutrons. So that's why we call them as isotones. Next is isoelectronic species. Iso means same. Electronic means electrons. So when different atoms have got the same number of electrons, then they are called isoelectronic. Now definitely the different atoms have different number of electrons, so it will be different types of ionic species. So for example, N2. In N2 there are total of 14 electrons. In CO, carbon 6, oxygen 8. So there are 14 electrons. In Cn negative, carbon 6, nitrogen 7. Since they are carrying -1 charge, so we have to add it. So the total becomes 6 plus 7 plus 1 means 14 electron. So these are the isoelectronic species. Next is nuclear isomers. So what are nuclear isomers? Nuclear isomers are the atoms with same atomic number and same mass number but with different radioactive properties. For example, the uranium has one type of uranium, it has got the half-life period 1.4 minutes, and the other nuclear isomer of uranium has got the half-life period 6.7 hours. So element is same, atomic number is same, mass number is same, but they have got the different life period, half-life period. So that's why they are called nuclear isomers. Last is isosters. So what are isosters? Molecules having same number of atoms and also same number of electrons are called isosters. For example, N2 and CO both have got 2 atoms. N2, its elemental molecule, diatomic, means 2 atoms. CO, heteroatomic, diatomic molecule. So 2 atoms. So they have got the same number of atoms as well as same number of electrons. That is 14 each. So that's why they are called isosters. Now next is electromagnetic radiations. Now electromagnetic radiations, before I proceed, now according to Newton, light was regarded as a stream of particles called corpuscles of light. Now particle nature could explain many phenomena such as reflection and refraction associated with light. But on the other side, it failed to explain interference and diffraction. So corpuscle theory of light was replaced by wave theory, and wave theory was given by C. Huygens. Now in 1870, James Clerk Maxwell stated that light, X-rays, gamma rays and heat, they emit energy continuously in the form of radiations or waves, and the energy is called radiant energy. And these waves are associated with electrical and magnetic fields. So the radiations which are associated with electrical and magnetic fields are called electromagnetic radiations. When an electrically charged particle moves under acceleration, alternating electrical and magnetic fields are produced and transmitted. These fields are transmitted in the form of waves, and these waves are called electromagnetic waves or electromagnetic radiations. The main points of electromagnetic wave theory are: number 1, the energy is emitted from any source continuously in the form of radiations and is called radiant energy. Number 2, the radiations consist of electric and magnetic fields, and these fields oscillate perpendicular to each other and also perpendicular to the direction in which the radiations propagate. Look at the diagram. Here we have got 2 perpendicular fields, electrical and magnetic field, and they are not only mutually perpendicular but also they are perpendicular to the direction in which the radiations propagate. Now the next point is that these radiations, they travel with the speed of light. And number 4 is these radiations do not need any medium for propagation. Next is limitations of electromagnetic theory. Limitations. The very first limitation of this electromagnetic wave theory is it was not able to explain the nature of radiations emitted by black body. Number 2, the ejection of electrons from the surface of certain metals when light radiations strike the surface. Number 3, the spectral lines emitted by certain elements. These spectral lines are called line spectrum, and line spectrum is really helpful in the identification of elements. We will discuss these points in detail, but before that, let us talk about the characteristics of electromagnetic radiation. Now, let us talk about few characteristics of the waves. Now, the number 1 here is wavelength. So, what is wavelength? It is the distance between two corresponding points on a wave. Means distance between two consecutive crests or two consecutive troughs. The units of wavelength are angstrom, millimicrons, microns, nanometers, picometers. 1 angstrom is always equal to 10 raised to power minus 10 meter. 1 micron, 10 raised to the power minus 6 meter. 1 millimicron, 10 raised to power minus 9 meter. 1 nanometer, 10 raised to the power minus 9 meter. 1 picometer, 10 raised to power minus 12 meter. Next is amplitude. So what is amplitude? It is the size or height of a wave. Means height of the crest or depth of a trough. That is called the amplitude. So it is the height. Number 3 is the frequency or nu. It is a number of wavelengths which pass through a point in 1 second. Now the units are cycles per second or hertz. Hertz after the name of Heinrich Hertz, who defined this thing. Next is velocity. So what is velocity? Velocity c of the wave, it is the linear distance traveled by the wave in 1 second. So c is always equal to nu lambda, means frequency multiplied by wavelength. Next is wave number, nu bar. Nu bar may be defined as number of wavelengths which can be accommodated in 1 centimeter length along the direction of propagation. So number of wavelengths per centimeter is called wave number. Remember, nu bar is always equal to 1 upon lambda. Means wave number is reciprocal of wave length, 1 upon lambda. So what is the relation between wavelength, frequency and wave number? That is c is equal to lambda into nu. We know that lambda is 1 upon nu bar. So nu is equal to c nu bar. Nu equals to c nu bar. Now coming to electromagnetic spectrum. So what is electromagnetic spectrum? It is the arrangement of different electromagnetic radiations in order of increasing wavelength or decreasing frequencies. Now frequency decreases in the following order. Cosmic rays having the maximum frequency and radio waves have got the least frequency. That means we can also say that cosmic rays have got the lowest wavelength, whereas radio waves have got the maximum wavelength, since frequency and wavelength are inversely proportional. So cosmic rays are the most energetic rays and radio waves are the least energetic radiations amongst these. So cosmic rays, gamma rays, X-rays, UV, visible, IR, microwaves and radio waves. This complete range of electromagnetic wave is called electromagnetic spectrum. We have already discussed spectrum in our class 10, but there we have read only about the visible spectrum. Visible spectrum means VIBGYOR. Visible spectrum has got a range of 3.8 into 10 raised to power minus 7 meters to 7.6 into 10 raised to power minus 7 meter wavelength, or their frequency range is 7.89 into 10 raised to power 14 to 3.85 into 10 raised to power 14. Now different radiations have got different effect. For example, radio waves. Radio waves are radio captures radio waves, and radio waves are emitted by stars also and gases in the space. Microwave we are using for cooking in microwaves. Infrared, night vision goggles, they pick up IR radiations which are emitted by our skin and objects with heat. Next, visible, our eyes are able to detect only visible spectrum, means different colors, different types of lights. UV, ultraviolet radiation, it is emitted by the sun, and of course it is responsible for the tanning of the skin or the skin burns. X-rays, X-rays we use for taking the internal pictures, for taking the internal picture of the tooth also. Next, gamma rays, they are used by doctors for taking the images inside our body, and biggest gamma ray generator of all is the universe. So here in the diagram there are all the radiations with their probable uses.